The algae are naturally occurring biomass, so we are using nature to heal itself. That's the concept. And we can see that we've already got naturally occurring isolates or naturally occurring agents that can do exactly what we would want to do at a lower cost and with just a bit more monitoring. So what happens in the lab is basically we have these naturally occurring algal isolates that we then create a co-culture with, meaning we just grow two different species together of the same genus of chlorella. We upscale them with our patented medium, which uses certain salts to increase or optimize the growth rate and the ability of the co-culture to uptake nutrients. And then we kind of upscale that into a pilot in a wastewater treatment work system like this one.
The CSIR was looking for a wastewater treatment works that can assist them with the project, and they needed a coastal municipality to assist with the coastal side of it. So we had some E. coli issues, and with this project it has basically reduced the E. coli in the groundwater. In the beginning it was easy for us because it's less operational, no electrical, no mechanical, it's just manpower and it's light work. From the groundwater monitoring test that was done and performed, there's like a river downstream where water is also being abstracted for agricultural purposes. And with this technology, it has improved the groundwater. Since we don't have an effluent that goes out directly to the river, we are impacting the groundwater. And I think the farmers is mostly more happy about the type of effluent they're getting for agricultural purposes.
When we mass culture the algae in the lab, we provide them as a pure mass co-culture. We normally transport them in about 25 or 20 litre starting volumes, and then we have a training manual that we provide to the municipality in terms of how much volumes of water to add per volume of algae, and then the amount of nutrients that they need to add from our patented culture medium. And then that's how they actually build up the culture in bioreactors, and the algae grow naturally using light and a bit of the nutrients. And so when they're exposed or released into the effluent, they then do a similar process of uptake of nutrients, and they outcompete other indicator pathogens as well as other algae or microbials in the system. And by outcompeting them and dominating the ecosystem, they take up the nutrients. And that's basically the concept of how the water treatment improves. So they uptake nitrates and phosphates, reduce the chemical oxygen demand, and we've also seen that they are able to suppress some of the indicator pathogens. For this specific case study, we measure the outlets of each of the 7 ponds. The idea is to look at the starting conductivity, pH, the chemical oxygen demand, and also the microbial load, specifically looking at E. coli and coliform most probable numbers. And we watch that reduce or increase as the algae continue to be released and dominate each pond. We've also seen a reduction of up to 90% of nitrates and phosphates. So we get a 10,000-fold reduction in pathogens or indicator pathogens such as E. coli. So what it means is that we get improved water quality, which then obviously fulfills the mandate in terms of improving people's lives through science. And also it also brings an awareness of green technologies. So what it does is it will improve the resilience overall. As there's awareness of these kinds of technologies, we have a certain level of resilience towards climate change, awareness towards the appreciation and different technologies or what nature can provide as opposed to the general anthropogenic sources that we normally rely on. And we also want to actually look at a market in industry as well. So not just supporting municipalities that need this treatment most, but also looking at offering it as a cost-effective solution for industry who actually have the infrastructure and the funding, but might benefit from a more low-cost and obviously environmentally feasible kind of alternative.
Nature-based solutions is the way forward. There is definitely place for nature-based solutions in a more advanced world of wastewater treatment.